Hi and welcome to the Velta Potential. This is the first video of a longer series where I will go into fundamental concepts within electronics and power electronics. In this video, we'll touch upon what power electronics is, and then we will look into the basic principles of an ACDC switch mode power supply which we're currently designing. So without further ado, let's go check it out. So this first video is about power electronics. Try to remember this definition. Power electronics is the study and application of electronic circuits used for the efficient conversion, control, and conditioning of electric power. That's at the heart and core of power electronics. And maybe starting out hearing this sentence, it kind of goes to your head a little bit, honestly. At least that's how it was a bit for me in the beginning. But let's look into what it really means on a fundamental level, because it's not all that complicated to understand what our goal is in power electronics. So I drew up a simple block diagram which shows essentially what the goal of power electronics is, or power conversion. It basically tells us that we take some input power. The input power has some electrical properties, which we're not going to go into right now, but let's just say that it's unique for this specific block. And our design aims to achieve another set of electrical properties, which is the output power. So, and I'm gonna not color them too much, but we take some input power and we want some output power based on some design documents or something from a customer or whatever to fit into that specific application. So we have to convert it, and that's what the conversion stage does. It takes those input power properties, convert it to an output power. And the way we convert it efficiently according to the design properties is that we take a feedback from the output power into a control circuit or a control IC, or it doesn't really matter. We control it. So we control the conversion with a feedback and some type of reference in order to make sure that this conversion is happening the way we want them. I hope that is clear. Let's see. Moving on to a ACDC switch mode power supply, and here too I urge you to pause the video and look through all of these boxes, because they're basically, and I'm going to remove this so I don't confuse anyone looking into this specific block diagram. But I built it to show the different stages of a switch mode power supply. You can have an input stage, some filtering, rectification, active power, factor correction, a switching stage together with a controller. And you can draw some parallel to the previous pictures. So go back and look. And you can see that they kind of follow the same pattern a little bit. Then you have the transformer stage, or I'm not sure a better name for this. Let's say the transformer stage, another rectification, some filtering, and then you have your output. And in this case, it's 12 volt, which is according to our design that we're working on. We're taking in a universal input and we want a 12 volt output. So let's look into the different stages of AC/DC switch mode power supply. And I've tried to illustrate the best way I can. So if it's not 100% accurate, my apologies. Do some your own research a little bit if if this image doesn't do it for you. But the stages follow the same type of pattern as the first general block diagram of power electronics, but also more the actual ACDC power supply block diagram. So here we're looking at a signal from a voltage, in this case, over time. And we're looking at the different stages here. So that we got an input stage, filtering, rectification, active power factor correction, smoothing, switching, rectification, and another smoothing. And this is coupled a little bit to the actual circuit that we're creating. So in the case where you're plugging in a device to the socket, to the wall socket, so in the case of a universal input, you get an AC signal. I've illustrated this with a black signal. And the red part is noise. So that's something that you can expect plugging your appliances into the wall socket. You can expect some noise. And this is where the filtering stage come in. And I haven't drawn any parallels to the specific devices that you might be using in these cases, but I'll mention them now. In filtering, you would use in filtering you would use a filter, so an EMI filter more specifically, which would filter out the high frequency noise from the socket. So you have a cleaner AC signal. Then you go through a rectification stage, which essentially using a bridge rectifier, which we do, chops off the negative portion and basically flips it. So we get more of a pulsed DC signal. The active power factor correction is something I won't go into detail right now, but I've illustrated a little bit what the goal of that is, so what the purpose of active power factor correction is, to make sure that both the voltage and the current of the signal is in phase, meaning that you don't lose power or waste any power. Let's leave that for a different video in the future, where I will go more into detail on that as well. So, but let's say that the goal is to have a power factor of 1, which means that the current is in phase with the voltage. Then we have a smoothing stage, which again uses capacitors in order to have a DC signal. So in this case, we have a DC signal. You see the capacitor charging and discharging. Then it goes through a switching stage, which is essentially the MOSFET, which switches the current in the transformer so that the magnetic field expands and collapses accordingly, making sure we can transfer that energy from the primary side to the secondary side. And then we go through a rectification stage again, where we essentially chop off the negative portion. So this is just a half wave rectifier, which we again smooths out with a capacitor, and we get a clean DC output. And please notice that there's a difference in amplitude here. So in our case, we're taking a very high AC signal and transform it down into a lower DC voltage. But yeah, that is basically it. And this is what we're currently designing. For the time being, I won't go into the exact circuit that we're building, but I will make more videos in the future about all of these concepts in order for me to learn and in order for me to teach you and have some fun with it. Please join me when I'm streaming. We're currently designing a ACDC switch mode power supply, so please come and check that out. And let me know in the comments what you thought about this video, if it helped you understand the basic principles of power electronics, but also AC/DC switch mode power supplies. It's complex topics, so I hope it sparked some interest and you have some questions. So please ask me in the comments. Until next time, ciao.